Of the over 4,000 exoplanets discovered so far, one of the strangest has to be WASP-189b. This ultra-hot Jupiter orbits so close to its star that its surface temperature could be up to 3,200 degrees Celsius, which is hot enough for iron to evaporate. Now, astronomers using the CHEOPS Space Telescope have investigated WASP-189b's atmosphere and found that it's just as odd as the planet beneath. It's not easy to investigate the atmosphere of an exoplanet, but in this case, the researchers were able to look at the light coming from the extremely hot nearby star. We measured the light coming from the planet's host star and passing through the planet's atmosphere, lead author of the study, Bibiana Prinath, explained in a statement. The gases in its atmosphere absorb some of the starlight, similar to ozone absorbing some of the sunlight in Earth's atmosphere, and thereby leave their characteristic fingerprint. With the help of, we were able to identify the corresponding substances. The team found indications of gases including iron, chromium, vanadium, magnesium, and manganese. One substance that was indicated and is particularly intriguing is titanium oxide, which could act similarly to the way ozone acts in Earth's atmosphere, absorbing ultraviolet radiation. There were also differences between what the team predicted and what they actually found, which suggests that the exoplanet atmosphere could be complex and affected by strong winds, having different layers which are composed of different gases. While Earth's atmosphere has layers, the assumption when studying exoplanet atmospheres has often been that they would be more simple. But this research shows that isn't necessarily the case. In the past, astronomers often assumed that the atmospheres of exoplanets exist as a uniform layer and try to understand it as such, said co-author Jens Hoijmakers. But our results demonstrate that even the atmospheres of intensely irradiated giant gas planets have complex three-dimensional structures. We are convinced that to be able to fully understand these and other types of planets, including ones more similar to Earth, we need to appreciate the three-dimensional nature of their atmospheres, agreed co-author Kevin Hung. This requires innovations in data analysis techniques, computer modeling, and fundamental atmospheric theory. The research is published in the journal Nature Astronomy.